Good morning everybody. Myself Dr. Harsimran Kaur, Senior Resident in the Department of Maulana Medical College, Ambala. Under the guidance of Dr. Ram Nandan Prasad sir, I today want to discuss with you anesthesia machine, which is a very important topic. This will discuss it in two parts. First the boyle apparatus and the modern anesthesia machine. One by one we will go with each in detail. Thank you. So what is first of all an anesthesia machine? Anesthesia machine is a machine which delivers a fixed proportion of mixture of gases which includes both the life-sustaining gases and the anesthetizing gases. The anesthetizing gases include isoflurane, sevoflurane, desflurane, and the life-sustaining gases include oxygen. So they will give a fixed proportion to the patient. Today's anesthesia machine was first of all designed in 1970, popularly known as boyle apparatus, which was introduced by Edmund Gaskin Boyle in 1970. Now today's machines are known as workstation. What is a workstation? Which includes both the life-sustaining gases, anesthetizing gases, the techniques for scavenging everything, and a record-keeping system. This is all the parts of a workstation. Now first of all, before I start discussing the machine, there is a pressure system which has to be discussed, which includes the high pressure system, intermediate pressure system, and the low pressure system. High pressure system, please remember, it has oxygen at 2000 psig and nitrous oxide at 760 psig. This oxygen and nitrous oxide, when they come to the level of machine from that high pressure system, it has to be reduced by a reducing valve to, in the cylinders, in the low pressure system we have the cylinders and the pipelines, which includes cylinders have a psig of 45 to 50 and the pipelines have 40 to 50 psig. So from 2000 to 40 to 50 there are reducing valves which will reduce. And the last is the low pressure system. Now first of all, what are the three parts of high pressure system? High pressure system includes the hanger yoke assembly, the pressure reducing valve, and the gauges. These three things, hanger yoke assembly, which is for fitting the cylinder, the gauges, which will tell the cylinder pressure gauges, and the pressure reducing valve. This one, pressure reducing valve, is for oxygen, and the other side, this pressure reducing valve, this pressure gauge is for nitrous oxide. So if three things are to be discussed in high pressure, it is going to be hanger yoke, gauges, and the reducing valve. So just first pressure regulator. These three things are included in the high pressure system. When we come on to the low pressure system has a psig of just 5 to 8 psig above the atmospheric pressure. It includes 5 things in it. This APL valve, pressure limiting valve, is included in the low pressure system. This back bar on which the vaporizers are mounted, this is included in the low pressure. Second thing is vaporizers. The third thing is this flow control knobs. These are included in the low pressure system. The common gas outlet, this is included in the low pressure system. Apart from these three things which I discussed in the high pressure system and these 5 things which I discussed in the low pressure system, everything else belongs to intermediate pressure system. So if someone asks you what is pipeline, is it intermediate? It is intermediate. Pipeline inlet connections are intermediate. The flush valve, it is intermediate. Anything else, secondary stage pressure regulator, everything will be intermediate. So just 3 things in the high pressure, 5 things in the low pressure. Rest everything is intermediate pressure system. So starting with first of all the cylinders, the high pressure system. The high pressure system, this is the hanger yoke assembly. This is the swivel gate through which we can fix the cylinder. The cylinder has a nipple on itself through which it can fix to the hanger yoke assembly. From the cylinder, the gas plunges into the machine. These cylinders, they are also included in this intermediate pressure system. Now when they come on to this is a pressure reducing valve that will reduce 2000 psig or 780 psig of nitrous to the 45 to 50 psig pressure. This is the pressure regulator which is going to reduce it, pressure reducing valve. And isme kitna pressure hai, this will be told by this gauges. Okay. Now from here the gas enters, this enters here from the pressure regulator, and from here it goes to the flow meters. Here these are the flow meters. These flow meters will have nitrous and oxygen. It will take the life sustaining gases from here, oxygen and nitrous, and then from here it comes back down, and here is the circuit which switches this machine into open or closed. So from here this is the open circuit, and this part from here going towards this part, there the soda lime canisters, the gas goes inside this and then into these expiratory and inspiratory valves, then to the patient. This is a closed circuit. This closed circuit can be turned on from this. This is open and this is closed. So we can turn this machine from open circuit to a closed circuit which will include all of these parts. This new parts in today's language, it is circle system, which will include the inspiratory valve, the expiratory valve, soda lime canisters, APL valve. So this all comes in the closed circuit. Here there is the oxygen flush valve. See, as we can see, the oxygen is coming from here. This is the pressure regulator from which it is going. After this is the oxygen valve through which it is having a flow of 35 to 75 liter per minute. Oxygen flush valve is very important for emergency situations when the patient is desaturated. But there are many hazards of oxygen flush valve. Since the oxygen is flowing at a flow rate of 35 to 75 liter per minute, so this large pressure, it can cause barotrauma. It can cause atelectotrauma. There can be accidental leakage from this oxygen flush valve. There can be some thing which fixes it up. So these are all the side effects of the oxygen flush valve. So as we can see in this machine, these were the pressure gauges, these were the pressure regulators. This is the circuit which is shifting it into closed and open circuit. This is the oxygen flush valve. This is the part of open circuit where we can attach the breathing circuit. So here the breathing circuits can be attached. We can attach veins to it. We can attach any kind of circuit to it. Now coming on to this, after this, when this comes out here. This is the nitrous which is coming here, and from this side we can see this is the oxygen which is coming here. This system is known as nitro lock system. What is nitro lock system? Nitro lock system works on the principle that if oxygen falls below a particular PSIG, nitrous oxide does not get leaked. This level is fixed in different machines are different. In Datex Sonda, in other machines, it will have 30 PSIG or 38 PSIG. Whenever oxygen falls below that level, nitrous oxide does not get leaked. It is actually a master-slave mechanism in which the master is oxygen and the slave is nitrous oxide. Coming from here, this is the Richter whistle. Richter whistle is an alarm which comes as soon as oxygen falls below 30 PSIG. Within 5 seconds, this whistle starts alarming. This whistle is for 7 seconds, which shows that if oxygen will fall below that level, machine will give an alarm. This is oxygen fail-safe device mechanism, which is here. Apart from that, this machine has many safety features. Anesthesia machine has many safety features. Why are they? So that accidentally also we do not give wrong gas to the patient. So if I start with the safety feature of the machine, first of all, these beads which are black in color, these are anti-static in nature to prevent any electricity conduction. Then there is a lock which is called, so that the machine stays at one place, there is a lock in this machine. Then coming on to the cylinders, these cylinders are color coded. As we can see, this oxygen cylinder is black body and white shoulders, and the nitrous oxide cylinder is blue body cylinder. The carbon dioxide cylinders are grey in color. The helium cylinders are brown in color, and the air cylinders, they are opposite to this. They are white body and black. So this is all color coding of the cylinder so that we do not attach the wrong cylinder. Even if you attach by some way or there is some mixing, there is a pin index safety system in this machine. What is pin index safety system? That only a particular cylinder with a particular pin can attach here. For we can say 1,5 it is air. For 2,5 it is oxygen. For 3,5 it is nitrous. For 1,6 it is carbon dioxide less than 7%. For 1,7 it is 2,7 it is carbon dioxide more than 7%. And for 3,7 again there is a pin index safety system that is 7, that is for anti-knock. So this pin index safety system is a very important safety feature. So first is the color coding of the cylinder, second is the pin index safety system. There are also pipelines which are coming from the outlets, that is according to this index safety system, diameter index safety system, so that only a particular pipeline can attach in a particular circuit. So coming on to the next, as we can see, these pressure gauges, they are also color coded. White, black for oxygen and blue for nitrous, so that even if there is some problem or some electricity is less in the OT, you can see it properly. Today's flow meters are also light, they enclose the light in itself, so that if electricity goes, you can at least see. Coming on to the flow meters, if we see the safety feature here, the nitrous oxide and oxygen, they are again color coded, white and blue. The flow meters also have a bobbin which is of blue and golden color, which again show that. Then the striations on these are also different, so that we can have a feature. Then again this is having broad striations in between, and these are very very thin striations, so that even the touch coded is also there. Then coming on here to the vaporizers, as you can see, the vaporizers are also color coded. The isoflurane is blue in color, and the sevoflurane, it is also yellow in color, and the desflurane is different color. These are again so that we do not mix the vaporizers. This filling of the vaporizers is also by different ways so that rightly the vaporizers can be filled with the right anesthetizing gases. Here there is a selector tech arrangement in the vaporizer. What is the selector tech arrangement? This is that when one vaporizer is open, you cannot open the second vaporizer at the same time, which means that you can open only one vaporizer at one time. So that is known as the selector tech arrangement. There is also APL valve, which is a pressure reducing valve. Again, a safety feature, pop-off valve is also known as. So that if there is excess pressure, this pop-off valve, like a whistle in a cooker, is going to pop off and all the excess gas will be out from here. As we can again see here, this is also the safety feature of the machine, that master-slave mechanism of the nitrous oxide and oxygen, so that patient does not have a hypoxia. Richter Whistle and oxygen fail-safe device. These are all the preventive measures so that we do not have hypoxia to the patient. Apart from these, there are also other safety features like in the pipelines we discussed, cylinders, vaporizers, in the pressure reducing valve. These are all the safety features of the machine. Now discussing with you this soda lime canister. What is soda lime canister? This is soda lime canisters are added to provide alkalinity. As you all know, sodium hydroxide is alkaline in nature. What it is going to do is, it is going to absorb carbon dioxide. So sodium hydroxide plus carbon dioxide, it is going to form soda bicarbonate. That will keep whole of the circuit alkaline in nature. This has granules of sodium hydroxide, barium hydroxide. There are two types, soda lime and bara lime. In soda lime we have sodium hydroxide, calcium hydroxide and water. In bara lime we have barium hydroxide also included in it. These are put in granules, small sizes, so that whenever gas passes through it, there can be more surface area for that gas to give out its carbon dioxide. Had it been just one block, the surface area would have been less. So more the number of granules, more will be the surface area for absorption of carbon dioxide. And silica is added for hardness in this circuit. And these are more the mesh size, more will be the absorption of carbon dioxide. Now, so again, continuation with our boyle separators, as we were discussing, I want to show you the modern anesthesia machine. This modern anesthesia machine has been modified electrically, pneumatically and mechanically by the boyle separators. So first of all, we will discuss the electrical modification. In the electrical modification, starting with the master switch. This master switch is an electrical switch. This can be for on and off of the machine. This electrical switch has a UPS which is attached like a UPS we have in our common processing unit, so that if by chance the back supply goes off, there is a reserve power with the machine and the machine can remain working. Now coming on to the electrical component again, here there are electrical outlets which you can see at the back of the machine. These electrical ports are for attaching the circuits. As I had discussed with you, high pressure system has hanger yoke assembly. So this hanger yoke assembly is in this modern anesthesia machine. This is hanger yoke assembly which is giving an attachment to the cylinders. This is a part of high pressure system, but the cylinder pressure regulators and the gauges which we could see in the boyle separators are not visible in this machine. Again, this is the pipelines which are coming, which were not in that machine. These pipelines, as I told you, are color coded. These are color coded for nitrous, air and oxygen. So this color coding of the pipeline, this pipeline comes out here. As I had already told you that this pipeline pressure, it comes in the intermediate pressure system. So this is the part of intermediate pressure system where the pipelines are at a PSIG of 45 to 50 PSIG. So this is the part of high pressure system. This is the intermediate pressure system which we can see. And coming on to the last, low pressure system. As I had already told you, the flow control knobs are no longer here. This is the mounting system of the vaporizer which is a part of low pressure system. APL valve is there which is a part of low pressure system. And a common gas outlet is there which is again a part of low pressure system. There is also an auxiliary oxygen control, that if the oxygen is by chance not working, there is an auxiliary oxygen supply which can work for that much time. This is the oxygen flush valve, as we had discussed. Oxygen flush valve is a part of intermediate pressure system, has a flow of 35 to 75 liter per minute. This is the oxygen flush valve for these modern machines, and this is the common gas outlet. This is the circuit which is for turning this machine into open and close type. So again, this is this. And this APL valve also has a part where we can hand ventilate the patient and machine ventilate the patient. So this circuit is for hand and machine ventilation. This part which comes here is the circle system that has the inspiratory valve, expiratory valve, the whole circuit to the patient. It goes on till the patient. These are the pipings which are going to connect to the patient. So this is there, and apart from this, going in the circle system is this soda lime canister. As we had discussed, soda lime canister, inspiratory valve, expiratory valve, APL valve for turning it into hand and back position. All of these are parts of circle system which come in the modern anesthesia machine. This modern anesthesia machine is actually a workstation. This workstation has all the anesthetizing gases, life-sustaining gases, oxygen, and this is the record keeping, and there is a table so that we can place the articles. This all comes in the modern anesthesia machine. So now this is also a monitor which I want to show you what all it is showing here. Whenever the patient is on ventilator, he is under general anesthesia, we can see the oxygen and nitrous oxide, which we used to see in the flow meters. This nitrous oxide is blue, which is again a safety feature. This oxygen is white. Here we can see the flows and liter per minute at which the oxygen and nitrous oxide are going. We can also read here that oxygen is 40% and the total flow which is going is 2 liter. 2 liters per flow is actually today's low flow anesthesia, which is for better scavenging and decreasing the OT pollution. This is the ventilator mode on which the patient is going, which shows the volume control mode, at what tidal volume, what respiratory rate, inspiratory, expiratory, and what P positive expiratory pressure has been applied to the patient. This is the P peak, which is the airway pressure at this time, the flow minute ventilation of the patient, which is 4 to 5.6. This is the end tidal carbon dioxide, which is very important monitor again. So we'll discuss all of these monitors and rest of the parts of machine in details in further class. This is a basic introductory class for telling you the parts of the anesthesia machine, both in the boyle operators and in the modern anesthesia machine. In further classes we'll discuss each of the parts in detail.